Everybody, I hope you all are doing great. This is the seventh video of this DP series, and congratulations on completing a week of daily uploads and trying to solve a problem of DP daily, right? So we are going to see a new problem today, which is unique paths 2, right? Pretty similar to previous problems itself and based on 2D DP itself. Let's read the problem. You are given an m cross n integer array grid. There is a robot initially located on the top left, that is grid 0 comma 0. Okay, the robot tries to move to the bottom right corner. All right, the robot can only move either down or right at any position in a time, like pretty similar to the last question itself. An obstacle and space are marked as 1 or 0 respectively in a grid. Okay, an obstacle is 1 and a space is 0. A path that the robot takes cannot include any square that is an obstacle. So of course we cannot step in on obstacle. That's what they're trying to say. Return the number of possible unique paths that robot can take to reach the bottom right corner. Definitely you can see in this kind of test case, robot, there are only two paths possible if the robot travels from this direction or the robot can travel in this direction. In this case, there is only one path possible, right? So at one point robot is only allowed to move right or down, and we cannot step on obstacles itself, right? Let us analyze this problem and let us try to understand this problem, and then let's try to solve it. So we are on the board itself, and let us analyze. We have to reach this bottom right cell. So robot can take this path, right, down, or robot can take this path, down, right. Of course, obstacle can be, instead of here, obstacle can be here as well. So in this case also, right, down, and another path is down, right, down, right. If the obstacle is here, let's say how many number of paths are there. So down, right, and right, down. Is there any other path using this? Right, down, this is also third path which is possible, right? Down, right, right down, and right, down. These are the three paths which is possible if the obstacle is here. Of course we cannot step on this cell and we have to reach the bottom right cell itself, right? Let us now try to analyze this test case only. I think this test case seems a little bit better test case than what is given in the question itself, and let's try to make a recursive solution out of this. Now, in the last videos, we have achieved some recursion things itself. Here, a robot is only able to move right or down. So in recursive calls also, we can of course imagine that only two things are possible. Either we can go right or we can go down standing on I comma j, right? So what are right and down? So if I go right from I comma j, I'll reach I comma j plus 1. And if I go down, I'll reach I plus 1 comma j, right? These are the two things I can achieve. Let us try to look at these and let's see what we should do. If I start from 0 comma 0, definitely we'll be starting from 0 comma 0. I can go either right or I can go either down, right? So right or down, correct? Now of course I cannot step on obstacles. This we have to keep in mind. So if I go right, I'll be reaching 0 comma 1. If I go down, 1 comma 0. From here, if I go right, if I go down, these are the two things which are possible. Okay, so if I go right or if I go down, let me color the things with different colors, right? So 0 comma 0, 0 comma 1, 1 comma 0, right? From here I can go either right or I can go down, right or down. From this step, is if I go right, I'll be reaching from 0 comma 1. If I'm going right from here, I'll be reaching 0 comma 2. If I go down, I'll be reaching 1 comma 1, right? Let's try to explore the left side itself fully. So from here, if I go right or if I go down, right, down, you can definitely imagine if from this step, if I go right, I'll reach 0 comma 3, which is out of bounds, and out of bounds I'll directly return a 0 from there. That is 0 possible paths to reach the bottom right cell, because it is definitely out of bounds, which we have already seen in previous problems. If I go down, I go 1 comma 2, I'll reach 1 comma 2, and since I'm standing on 1 comma 2, what can I simply do? Since I'm standing on 1 comma 2, I'll simply say that 1 comma 2 is a valid index, right? 1 comma 2 is a valid index, and from here also it is possible to go right and down, right? I'll increase the speed a little bit. I hope this similar thing is we have done in the last question itself. So I reach, if I go right from here, I'll definitely reach out of bounds, 1 comma 3 I'll reach. If I go down, I'll reach 2 comma 2. Now from here, definitely we can see 0 will be returned, and this is also one of the base cases. If we are standing on bottom right cell, so I'll return what? I'll simply return a 1 from here, that we have reached the bottom right cell itself. Okay, this seems pretty easy. Now 1 comma 2 will choose what? Now 1 comma 2 have to make a choice, right? And this time choice is not how many, like what is the best approach, what is the closest, or what is the shortest approach. That's not the like, choice. Here I have to add everything. So 1 plus 1, how many paths from 1 comma 2? A single path is there from 1 comma 2 to reach, and I'll add 0 plus 1. I'll simply return the sum of 0 plus 1. I'll return 1. This 0 comma 2 will return what? How many paths are there from 0 comma 2? I can only travel downwards, right? There's no way to go right. So 0 comma 1, I'll return 1. 1 comma 1, how many paths to go to downward thing, to the bottom right cell from 1 comma 1? Let's try to explore right or down, right or down. If I go right from here, I'll reach 1 comma 2. If I go down from here, 2 comma 1. Now 1 comma 2, we have already calculated the answer. I can relate to memoization because we are again trying to calculate this answer which we have already calculated. So 1 comma 2, for 1 comma 2 I'll simply return 1, whatever we are returning here, right? I think you all are comfortable with me converting recursion code to memoization directly, right? And if you are not, you can definitely tell in comments that, some, if you are facing any problems in imagining what is memoization. This is a whole playlist I'm making, right? So in a playlist you have to watch the videos continuously. If you are directly joining in this video, it might be a little bit troublesome for you, right? But no worries. 1 comma 2, I've already calculated the result. I'll not again make calls. I'll simply return whatever result I calculated earlier. I'll simply return 1. 2 comma 1, have I calculated a result for 2 comma 1? 2 comma 1, no, I have not. So let's try to calculate the result for this. So R and D. So for R and D, if I go right, if I do a right call, I'll reach 2 comma 2. From this cell, if I go right, I'll reach 2 comma 2. From this cell, if I go down, I'll reach 3 comma 1, which is invalid, right? 2 comma 2, definitely it's a base case. So like, this is a base case. So this, from here we definitely return a 1, that yes, you have reached successfully the bottom right cell. 3 comma 1 is definitely not a base case, like it is out of bounds condition. So from here I'll be returning 0. Now 2 comma 1, how many ways to reach the bottom right cell from 2 comma 1? Only one way, to go right. I'll simply return the sum of 1 comma 0. I'll simply return 1. Now 1 comma 1 is having two ways. If it goes right, this is the way. If it goes down, this is the way. So two ways are possible to reach the bottom right cell. So 1 plus 1, 2 will be returned from here. For this particular cell, it will be 1 plus 2, 0 comma 1, 0 comma 1. I can go like this, I can go like this, I can go like this as well. So three ways are possible from this particular, we can say index, right? Let me erase this, yeah. So 1 plus 2, which will be simply 3, I'll be returning 3. Now, if I go 1 comma 0, 1 comma 0, this we have not calculated. Now, 1 comma 0 is a little bit peculiar case. From 1 comma 0, you can definitely see what is possible, right? Full focus. For 1 comma 0, you can see that, you know, I can go right. I can go right. Now, if I go right, I'll be reaching 1 comma 1, right? Okay. I'll be reaching 1 comma 1. If I go down, I'll be reaching 2 comma 0. This is a peculiar case, right? 1 comma 1, have we calculated the answer already? Yes, we have definitely calculated the answer already. And you can definitely see that, I'll be returning whatever answer I calculated earlier, 2 will be returned from this. 0 comma 2, yeah, this is an obstacle. And if we are standing on obstacle, there is no path to reach to bottom right cell from an obstacle. I'll return 0 from an obstacle as well. So I've returned this from here. And from here, I'll be returning the sum. So you can definitely return 2 from here, right? Now, while iterating over the test case, I was able to find 3 ways. Now you can see there are 5 ways. So if robot goes, let's see how many ways robot can go down. This is one way. Right down is another way. Down, right is another way. Right, down is another way. Down, right is another way. So total 5 ways are there to reach the bottom right cell, avoiding the obstacles to reach the bottom right cell from the starting cell itself. So 3 plus 2, 5 will be returned, right? And this is the recursive table for this recursive tree for this code itself. Let us try to write a pseudocode for recursive algorithm, and then we'll quickly convert recursion to memoization. So we'll be using the tree to write the pseudocode for recursion itself. Function. What are the parameters I'm passing? I'm passing, of course, the grid itself, which is array. I'll pass I and j. These are the indexes I'm standing on currently. The first thing I want to write in recursion is the base case. So first base case is if I am out of bounds. I'll do what? I'll return 0. And if I'm out of bounds, I'll return 0. If I'm an obstacle, obstacle, I'm spelling it wrong, but doesn't matter. If I'm an obstacle, I'll return obstacle. I think it's A. Obstacle. I'll return 0 as well. 0. Right. Because from obstacle, I cannot, go there. Right. So, all right. Okay. If one another base case is written, this is the base case. If I'm bottom right cell, I'll do what? I'll return 1. Return 1. Correct. Now, if I'm none of these special places, so I'll try to go right and down. So integer right. I'll call for the function arr. If I go right, I do I j plus 1. Integer down is what? Function array I plus 1 comma j. This is down. And what do I have to return? I'll simply return what? Return right plus down. And this is the whole recursive pseudocode for this problem itself. Let us convert this into the code itself and then convert it to memoization. So we are in the code itself. Let us quickly try to find the solution for this problem. And I'll just simply convert the pseudocode to recursive code itself, right? So I'll write a function public integer recur. I'll pass what? Integer 2D array grid, or I'll say array integer I integer j. These are the indexes I'm standing on. I'll do what? First the base cases. So if I is less than 0 or j is less than 0, right? Of course I and j cannot go less than 0 because we are always adding. So writing these are unnecessary, right? I'll just find out what is n, arr.length, and what is n. Integer n is equal to arr of 0 dot length. Correct. Now after finding these n and m out, I'll simply check if I is equal to n or j is equal to m. Right? If I or j are out of bounds, I will return 0. This is out of bounds condition. Out of bounds. Another condition is if arr of I comma j is equal to 1. If there is 1, this means that it's an obstacle, right? So obstacle, okay, it's A. So return 0 in this case as well, because there is no way to reach destination from obstacle, right? All right. I if these are done, if I'm standing on the bottom right self, if I is equal to n minus 1 and j is equal to m minus 1, number of rows, number of columns, definitely bottom right, return 1. There is, I found a 1, I found a way, I have found a way. Now for the rest of the cases, integer right is equal to recur for arr I plus I comma j plus 1, right के लिए I'll do j plus 1. Integer down is equal to recur for arr I plus 1 comma j, and in the end I'll return right plus down. This is the recursive code itself. Let us try to run and see if the base cases are passing. If these cases are passing, the sample test cases recur. And one of the students asked a doubt from me today, that why, like he asked that, I try to submit the code, but it is giving me TLD. And I asked them that, are you trying to submit the recursive code? These recursive codes will never actually give you the right. It will never give you accepted answer. It will always give you recursive, because that is what we are learning, right? We are learning to optimize recursion, right, from dynamic programming itself. So array, I'll pass 0 comma 0 as the starting point itself. So do not try to, that's why I don't, submit the recursive code only. I submit memoization and the other code itself. I do not submit a recursive code because I know that it will definitely give me a TLE itself, right? Let's try to run the test case. Let's see if it works. I'll change the name to array, and let me change the test case as well. Instead of having a 1 here, I'll have a 1 here. Like the, the test case we are iterating on. So it is accepting, and definitely this would run on the sample test cases, but it would fail because of time limit exceeded. Now try to convert this recursion code to memoized code. Now to convert to memoization, I'll simply do what? I'll make the copy of this same function. Of course, that's what we do in memoization, right? This recursive function I've copy pasted, and now what do I have to do? Wherever recursive is written, I'll change the name of the function to memo. Right, I'll pass a 2D DP as well, because two parameters are changing. I think at this point you are able to understand what dimensional DP I need, because two parameters are changing, I plus 1 and j. Look at these recursive calls. you can see that two parameters are actually changing shapes. Array I'm passing as it is, but sometimes I'm passing j plus 1, sometimes I'm passing I plus 1. So these are the parameters which are changing shape. So two parameters are there, therefore the DP will be of two dimensions, right? All right. First I'll do what? I'll pass DP array here as well, right? And now the work is to recall and remember. How do we recall, right? If, answer it now. If, you know, full focus. If what? dp of I comma j. If dp of I comma j is equal to 0, I'll say. If it is equal to 0, I'll return what? If not equal to 0, because if it is not equal to 0, this means that already calculated the answer for that. I'll return dp of I comma j itself. Else I'll do what? Else I will try to calculate the solution if I have not already calculated the solution. And after calculating the solution, I'll try to remember that solution. Right. This is the memoized code itself. Let me call this memoization function. I'll call this memoization function. Integer dp, I'll create new integer arr.length. This is the arr of 0. These are the dimensions I'll simply pass here for the DP array. And here I will pass the DP array as well in the memoization. I think we are not making any mistakes. Let's try to run the code and let's see if it is working. All right, it's getting accepted. Let's try to submit it. Now this is memoized code. This is optimized code. That's why I'm trying to submit it, and that's why we have submitted it, right? So definitely the code is getting accepted. Let us try to convert this memoization to tabulation quickly, right? So this at this point, I think you all are familiar how to convert a memoization to tabulation using the trick itself. I'll not waste a lot of time. Public integer tabulation, right? And I'll pass the array here, and I'll pass the DP array, right? Now, where will the loop start? Can you see that one of these base cases? We are trying to reach the bottom right cell. So can I start the loop from the bottom right cell itself? Right? Can I start the loop from bottom right cell itself? Let us try to start the root from bottom right cell itself. Let's full focus. Answer it now. For integer I is equal to, I'll first calculate n comma m as well. Just for is n minus 1, I greater than equal to 0, I minus minus. For integer j is equal to m minus 1, j greater than equal to 0, j minus minus. I'm starting from bottom right cell. Tabulation is bottom up. So I'm starting from bottom right cell. After starting from bottom right cell, what do I have to require? I'll copy paste this memoized code. Definitely, I'll copy paste this memoized code. This I have copy pasted from there. Now, let me remove these comments, because I think it is like pretty much clear to all of you that what we are actually doing. Or right now, let us try to see that what can we improve in this code and how can we convert into DP. So I have copy pasted the memoized code. What am I supposed to do? First of all, remove this recall condition, right? Wherever you are returning a value, just try to remember it and then return. So you can see this is an out of bounds condition, right? So I'll this condition will never happen, because I and m are I'm starting from from the bound itself. So I have to remove this line. It's of no use. This line on which I'm standing on obstacle, can I simply do this? I'm returning 0, right? I'll simply continue from this statement. Of course, what do I say? dp of I comma j is equal to 0 and then continue. But default value of dp of I comma j will be 0 itself. That's what I tell now, that wherever you are returning a value, remember that value in the dp and then continue. But there's no need to remember in this case. I can simply continue if there is an obstacle, right? So we'll simply continue from that case. Now here, this is a case when I'm standing on this I comma this bottom right. So I'll handle this case definitely. Return, remember and return. So dp of I comma j is equal to 1 and then continue. Remember and continue, this I've done. Right and down we'll handle in a little bit later. Here also there's a return statement. So convert all the return to continue statements. So remember and continue. So I'll remove this return statement. I'm remembering the result in DP, and of course that's this after this line the loop will be continued itself. There's no need to write continue here. So all the return statements have been converted to continue, right? Now the only thing which is remaining is look at this memoization. Look at this memoization, right? Wherever you are doing recursion calls, wherever you are doing memoization calls, only thing you have to do, just try to access the DP array ij plus 1. Here also you just have to try DP of I plus 1 comma j, right? This is it, right? This is it. This is what we are trying to achieve, right? Now j plus 1 and I plus 1 can go out of bounds, because that out of bounds condition we have to handle. ध्यान से देखना है. If I plus 1 is less than n, if it is less than n, then only try to access dp of I comma j plus 1, else try to write 0 in this case. And similar for this, I'll just remove this comment from here, this is of no use now. Similar in the bottom case itself, but here you can see j plus 1 can go out of bounds, so I'll write j plus 1 comma n. My bad, I have to write j plus 1 comma n. In this particular line, definitely I can go out of bounds, so I'll write if I plus 1 is inside the bound itself, inside n, then only I'll try to access the dp array, else I'll try to write 0 here itself. And this is it, my friends. This is the tabulation for this code. I'll simply return dp of 0 comma 0, and that would be the actual output, right? That would be the final result. So return tabulation. I'll pass here the array, I'll pass here dp, and then I'll run the code. Let's see if it is passing. Okay, so it is definitely passing, and yeah, so it is passing and it's working fine. It is getting accepted, right? So one thing is there, of course you can improve the space of this problem, right? You can definitely use the grid itself in order to consider a space, right? So you can do that if you want, but I of course have to explain you everything. So my code will be as easy to understand as possible. I'll not try to do things directly, because this becomes a doubt in a video, that why are we doing things directly. So this is the problem, unique paths 2. So congratulations on being consistent and completing 7 videos of this playlist. Congratulations on completing a week with me, those who are actually with me while the videos are getting uploaded. So congratulations to you all, and congratulations to those who are watching after getting these videos getting uploaded, after the whole DP playlist is complete, right? And I hope you all are enjoying the content. Do tell me in the comments what do you feel, because as soon as I get a comment, I get really excited to read that comment. So of course, comment as much as possible, share with your friends as much as possible. I only have you all people to share this content, so definitely much support would be appreciated. Thanks a lot for watching this DP, and I hope you are learning the tricks I am telling in these videos, and you can definitely see in these 7 videos. Tell me in the comment section that is DP easy, really easy, and that comment section will actually tell whether this playlist is making DP easy or not, right? So, and one thing, that I named this playlist DP is easy. I was going to name it DP made easy, but then I thought, no, DP is actually easy when you try to apply everything in a generalized form, and you try to look on a bigger picture of things, that what things are actually happening, right? What tricks we are using. DP is actually easy, right? So don't worry. Many of you will say till now it is looking easy, but let's see in the future. But don't worry, right? We are on a journey. We'll solve everything together. I hope you're liking the content. Please like, share, and subscribe, and ask your friends to also get on the challenge itself, right? So thanks a lot for joining in this video. Until the next video drops.